Dear learners, I welcome you all to this online teaching session. Today we will discuss about practical number 5, that is estimation of paracetamol and diclofenac sodium using absorption ratio method by UV spectrophotometry. So aim is to estimate percentage weight by weight of paracetamol and diclofenac sodium in given tablets using absorption ratio method by UV spectrophotometry. Reagents and chemicals required are standard paracetamol powder, standard diclofenac sodium tablet, that is our sample containing both the APIs, zero point 0.1 normal sodium hydroxide and distilled water. Sodium hydroxide is used for preparation of standard solution as well as sample solution, and distilled water is used for preparation of zero point 0.1 normal sodium hydroxide. Apparatus, you require volumetric flask of different size such as 100 ml, 50 ml, 10 ml, pipettes, beaker and funnel. Wattman filter paper for filtration of samples and standard solution, tissue paper for cuvette wiping. Of course, you require UV visible spectrophotometer, and weighing balance is required for weighing purpose. Drug profile, paracetamol and diclofenac, other parameters of both the drugs are depicted in this slide. Coming to preparation of standard solution as well as sample solution. Standard solution of paracetamol is prepared by dissolving 5 mg of paracetamol in 50 ml 0.1 normal NaOH. You can also prepare, if you have very high precision balance with you, you can also prepare 2.5 milligram. You can by dissolving 2.5 milligram in 25 ml of 0.1 normal NaOH. So this will give you 100 ppm solution. You have to sonicate the solution, filter it, and from the 100 ppm solution 1 ml is withdrawn and it is diluted up to 10 ml with 0.1 normal NaOH to get 10 ppm paracetamol solution. Diclofenac sodium solution is prepared in similar way. Dissolve 5 mg in 50 ml, sonicate the solution, filter the solution, and then do 10 times dilution. Then that means from this 100 ppm solution 1 ml is withdrawn and 10 up to 10 ml the dilution is done to get 10 ppm diclofenac standard solution. This is the sample to be analyzed. 20 tablets are taken. Average weight is determined by first individually weighing the tablet, 20 tablet, and then average weight is calculated. This is the average weight 637 milligram, and which contains 50 milligram of diclofenac sodium and 325 milligram of paracetamol. Now preparation of sample solution. As we know that tablet is having average weight 637 milligram, which contains 50 milligram of diclofenac sodium. So 50 milligram of diclofenac sodium is present in 637 milligram of tablet powder. Tablet you have to triturate it, 20 tablets, and you have to make powder. So that tablet 637 milligram of tablet powder contains 50 milligram of diclofenac sodium. So 10 milligram of diclofenac sodium contains how much, or 10 milligram diclofenac sodium is present in how much tablet powder? Means for 10 milligram diclofenac sodium how much tablet powder is required? So the answer is 10 into 637 upon 50, that comes to 127.4 milligram of tablet powder. This tablet powder is taken into 100 ml volumetric flask. Small volume of 0.1 normal NaOH is added. Sonication is done, and then final volume was made up to the mark, that is 100 ml with again 0.1 normal NaOH. Sonicated, the solution is sonicate. You have to sonicate it so that you can get proper dissolution of your API. So initially you will get 100 ppm solution of diclofenac sodium. From these 2 ppm solution having 2 ppm diclofenac sodium is prepared by diluting 0.2 ml to 10 ml. Now this 127.4 milligram tablet powder contains, along with diclofenac sodium, it also contains paracetamol, because this is the combined dosage form. So in this 127.4 milligram tablet powder, how much paracetamol is there, that we should know. So 637 milligram tablet powder, that is our average weight, this is our average weight, it contains 325 milligram of paracetamol. So 127.4 milligram tablet powder contains how much paracetamol? So the answer is 65 milligram of paracetamol, and this powder we dissolved in 100 ml. So indirectly we are dissolving 65 milligram paracetamol in 100 ml. So it comes to 650 ppm solution of paracetamol, and again 0.2 to 10 ml dilution is done. So final concentration of paracetamol will be 13 ppm. So sample solution contains 2 ppm of diclofenac sodium and 13 ppm of paracetamol. So we have 3 solutions with us now: diclofenac sodium 10 ppm standard solution, paracetamol 10 ppm standard solution, and sample solution, that is tablet powder solution 2 ppm and 13 ppm. Very important point, all the solutions needs to be filtered during preparation. Sonication is important and filtration of sample is important, especially in the sample part, because the sample is our tablet will have many other excipients, so filtration is must. Now both the solutions you have to simultaneously scan from 200 to 400 nanometer. These two standard solution you have to scan in UV from 200 to 400 nanometer. So you will get one point where both the sample will have same absorbance, they will meet each other. So this isoabsorptive point will be your lambda 1, and you can take lambda 2 as lambda max of any of the components. Here we have taken lambda max of paracetamol as lambda 2. Now you have lambda 1 and lambda 2. These two solutions you have to measure at both the lambda. Diclofenac you have to measure at lambda 1 and lambda 2. Paracetamol standard solution you have to measure at again lambda 1 and lambda 2. Means absorbance you have to find out. Now these absorbances will be used to get absorptivity. So you will get AX1, AX2, AY1 and AY2. And this diclofenac sodium sample solution you have to take absorbance at both the wavelength, and that will be your A1 and A2. So here our X is diclofenac sodium and paracetamol is Y. Wavelength lambda 1 is isobastic point. Here 282 nanometer is isobastic point or isoabsorptive point. Lambda 2 we have taken lambda max of paracetamol as a lambda 2. So 258 nanometer is lambda 2. So diclofenac sodium 10 ppm solution is measured at both lambda 1 and lambda 2 to get this absorbances, and absorptivity is calculated. Again paracetamol 10 ppm solution is measured at both the solution to get the absorptivity. How absorptivity is calculated? Small a is our absorptivity. So A is equal to ABC. So I will discuss for one reading, rest you can understand very well. So for A is equal to 0.692, what will be the absorptivity? So small a will be is equal to A by BC. So 0.692 into 1 into 1 is a path length and C is the concentration. Now our concentration was 10 ppm. So 10 ppm you have to convert into gram per 100 ml, because for absorptivity the concentration is expressed in gram per 100 ml. So 10 ppm comes to 0.001 gram per 100 ml. So absorptivity will be 692. So this is 692. Similarly, you can calculate AX2 for this, AY1 for this, and AY2 for this reading. And these are the readings for samples, absorbance only. So if you substitute all the values into equation, you will get the concentration, but concentration will be expressed in gram per 100 ml, because absorptivity was calculated using concentration unit gram per 100 ml. So that gram per 100 ml again you have to convert into ppm. Suppose the Cx is 1.54 ppm and Cy is 13 ppm is not 13 ppm, 12.9 ppm. So this is 12.9 ppm. So these are the values which we obtain from calculation, these two values. Now our theoretical value for diclofenac sodium is 2 ppm and paracetamol is 13 ppm, as we can see from here. So these are the theoretical values. So what will be the percentage purity? So in this way you can calculate the percentage of paracetamol and diclofenac sodium. The given tablet sample contains, the result can be given as the given sample of tablet contains 99.23% of paracetamol and 77% diclofenac sodium. So I thank you all for patiently listening. Have a good day.